My name is Chad Williams, and today we're going to talk about an independent samples t-test. So let's start off by making some data. So what I want to do is do cbind, and we're going to use the rnorm function, which we often do. We're going to say 50 participants per group, and then we're going to have a mean of 5 and a standard deviation of 2 for the first group. Then we're going to do the same thing for the second group, but let's do a mean of, let's say, 6, sure. And then still a standard deviation of 2. So what we get is our data here. And that's what we see here. So that's group 1, and that's group 2. Of course, as usual, change the call names. And I'm not going to be too specific about what this means. I'm just going to say group 1 and group 2 for now, because we just want to get to the point here. So group 1, group 2. So what we see is this is group 1 and this is group 2, and those are their values. Now I do like to plot my data a bit, so we could start with a bar plot, but we'll see it's not going to be too informative, and we're not going to put error bars on it. I could show you how to do that, but I'm not going to here. So what we want to do is get our call means of our data variable, then we'll see a bar plot, and it's just going to show us the two means in a bar function. So we see that group 2 has a higher mean than group 1, but we're not really sure what that means. Are they statistically different or not? I'm going to really quick also just plot our data a little bit more in depthly here. So I'm going to say long data equals the melt function of data. So what we're going to do is we're going to get our long function. So we're seeing, oh, ignore that, but group 1 and group 2 are now in one category, and then all their values are in this here. So I'm going to change the call names of long data. Just ignore that first one. I'm just going to make it, doesn't matter, NA. And then what we have is group, and then we have values. So what we have is the one we ignore, we have groups, and then we have values. So what we can also do is change the long data, the second variable, which is our group variable, or the second column, I should say, into numeric. So we never came across this before, but what as numeric does is it changes things into numbers. Here it's going to change my groups, and it's going to change them into numbers. And you see group 1 is now just the number 1, and group 2 is the number 2. So we could do a plot of long data 2 to 3. What we'll see now instead is all of our data points for each group. And you can see more of a spread there now. Instead of the bar plots, which aren't very informative, now we can see that group 1 has, still a mean of 5, but it goes anywhere from 0 to almost 10. And group 2 goes from about a little bit over 2 to a little bit over 10. So now let's see if they're statistically different. So I'm going to say t-test results as my variable name equals t.test, where we're going to use our normal data frame, so data 1 and then data 2. And so again, 1 is our group 1 and 2 is our group 2, and that's column 1 and column 2. Now if we run this, what we get is some results here. But before I go through these results, what I want to show you is this. So Welch's two-sample t-test. Now what this means is the default for this t-test function is to use the Welch's t-test, which is a modified t-test when the variances between the two groups are not equal. And so we don't want to use this unless if we do have unequal variance in our groups. But we know that they have equal variability, or they should have similar variability, because we actually designated that each of them has a standard deviation of 2. So instead of getting a Welch's t-test, we want just a normal t-test. So we're going to do comma var equals true. So what that means is the variance between the two groups are equal. And then yes, they are. Now the default for this is false, which means that they're not equal. So now if I rerun this, what we get is a two-sample t-test, not a Welch's two-sample t-test. And we start off with our degrees of freedom of 98, which makes sense because we have two groups of 50, which is 100, Then in this case, we have two groups, so it's n minus 2. We have our t-value of 3.4902 negative, and then we have a p-value here as well. We have two means, one for each group. So the first group mean was 5.1, which is pretty close to what we were looking for. The second one is actually 6.5, which actually is, still pretty close, but different than what we were looking for. But that's random sampling for you. We also have our confidence intervals of the difference between the two. And here we have a p-value that's less than 0.05, which is standard in stats. So these are two significantly different groups. And we can write this out as the following. T, with our degrees of freedom of 98, equals negative 3.49, p equals 0.0007. And there's our result right there. That's about it.